Actually, I have been involved in this technology for the last 25 years ago, and I have been in several places, though we have seen a very beautiful picture there in the video. More or less, we were also doing that kind of activities in the past, but that could not be commercialized in our context. So let us see what we have done already and what we need for the future. I would like to focus on that issues. The traditional biogas contribution here in Nepal is about 78%, whereas that of renewable energy is only about 1%. And almost about 2/3 of the people are using firewood as their main source of energy for cooking purposes. And about 56% of the Nepalese people have access with electricity. And we have so far installed about 300,000 domestic-sized biogas plants, and also about more than 200 institutional biogas plants, and about 60 community biogas plants. But most of the community biogas plants were installed in 80s. So why do we need large-size biogas plants? That is basically, if we talk with, since it is organized by World Bank, and I think I should thank to World Bank also to give me this opportunity to share my experience. But as per the SREP, the SREP project document, they have categorized the large-size biogas plant basically into 4 categories. That is, one is the commercial one, second one is the local authority, that is the municipalities, and the third one, the institutional plant, and the last one is the community biogas plants. So these large-size biogas plants are basically for generating power from the waste. And also it helps in improving the environment and also help in the wastewater treatment process, as we have already seen in some of the pictures just before. So that it can also provide some environmental sanitation in the nearby area. And we should be able to use the gas in a more commercial ways, as agro-processing or pumping water for irrigation or generating power for rural electrification and so on. The more important is the management of the waste. So the waste management is that is a human control of collection, treatment, and disposal of different waste. And that biodegradable waste that is broken down naturally by microorganisms, either by aerobically or anaerobically. But still there are some problems of handling these organic waste. So the waste disposal is a severe environmental problem, that is one of the major problems, and it also threats to many diseases, and it causes air, soil, and water pollutions. So accumulation of that wastewater and its natural degradation generates sometimes some poisonous gas. So the best way to treat that one is to install a biogas plant or a methanogenesis process and get the gas and slurry for our economic or benefits. So anaerobic digestion allows sewage and food waste to be converted into a gas that can be used for cooking or even to run engines to generate electricity. I think we have already seen several pictures just now. And the main problem with sewage is the feed waste that is usually mixed with solid waste, so it is diluted, and a more conventional sewage plant usually includes a settling tank as the first stage to separate solid materials from the water. And many such plants are used in anaerobic digester to process the solids, while the remaining liquids can be cleaned using the aerobic process. I think I would like to share some of the experience what we have already done as a research and development here in Nepal. It was mostly from 80s, because we are involved there. I think Dr. David Fulford is there. He was also part of the team. And Nanan Bhakta Pradhan, he was also the manager at that time. And we were developing something there in early 80s. But due to several problems, we couldn't continue it. And most of the plants are not functioning in the cases here. So with the support of USAID and UNDP, we have been involved in developing various designs of biogas plants that include the floating steel drum design, basically from 100 CFT to 1000 CFT capacity, that is the gas production capacity. And the fixed dome design, that is the most popular one, what we call GGC model 2047. Nowadays it is worldwide and moving not only in Asia but also in the African countries. And the tunnel design, though I think we have already made about 100 such plants, but that could not be commercialized. And the plastic biodigester and brick mortar dome, that I installed in our research sector as a pilot project. Then on top of that, we are also developing various biogas appliances. These include the gas pipe, stoves, lamps, water drains, mixer machines, manometers, gas tape, gas valves, and so on. At that time, there was only one company named GGC, or Gobar Gas Tatha Krishi Yantra Vikas Private Limited, shortly we call GGC, Gobar Gas Company. So right now, we do have more than 80 companies, so that we do have a good privatization of the technology here in the country. And we are also introduced the standardization of the design as well as appliances, and introduced the quality control mechanisms. That's why the success rate of the domestic size biogas plants is quite high. We are saying that more than 90% of the plant are functioning well. On top of that, we are also providing training to various group of people that include the users, the policy level people, the bank people, and so on. We're also using various alternative feedstocks, that is cattle dung, poultry droppings, pig manure, and in the lab, I have been tested with rice straw, eupatorium species, and some of the waste from the industries, that is the press mud, as you have already mentioned there, and also the waste from the brewery, and so on. Similarly, in most of the community biogas plants, the gas was used mostly for agro-processing, pumping water, and generating electricity. And we are also using the slurry to various crops, and the yielding capacity was quite high in most of the cases that we have applied for cereal crops as well as vegetables. Especially in winter months, the gas production is normally reduced, is almost by 50%. Then we try to develop some techniques to improve the gas production in winter months. And these are some of the techniques that we developed: the compost for heat generation, utilization of waste heat from biogas power generation. When we are using engines in a plant, then these engines are water cooling system engines, so that we have to circulate cold water in that engine. Once it is circulated, and then when it becomes warm, and then we recirculated that warm water through a GI pipe into the digester, so that we can increase the digester temperature and ultimately the gas production. And solar radiation, simple technology, and the insulation with rice straw. And we have also installed some cold climate and high altitude biogas plant. The first one that I installed was in Sorgadwari. It was in Piuthan district, about 7,000 feet, I think. And the plant is a 10 cubic meter capacity, and I think that plant is still running. I'm not quite sure right now, but I think I have visited that plant after 2 or 3 years installation, and that was running at that time. And also we used to test several biogas appliances, efficiency of stove, lamps, and so on. Similarly, as I mentioned before, that we have already installed 200 institutional plants. The size of these plants are basically from 6 to 75 cubic meter capacity. That is the total volume of the plant, not the biogas production capacity. And these plants are mostly fed with night soil, kitchen waste, poultry dropping, sewage, vegetable waste, cattle dung, and so on. And the 60 community plants that I mentioned before, and in these 60 plants, we are also having engines. These engines, the size of the plant is from 15 to 50 cubic meter capacity, and the size of the engine that we add to that plant is 5 to 8 horsepower engine, and these engines were basically from India, Kirloskar and USA at that time. But nowadays we do have engines totally run with biogas, because these are the dual fuel engines. And BSP SNB did not include the large size biogas plant in that program. I think you can also ask me that why it's not here right now, because at that time there was no policy, and SNB BSP has focused to domestic size biogas plants, not to the large size biogas plants, and there was no much support from the government as well. So that these plants, almost all of these plants are not functioning at the moment. So hence I have suggested that there should be the standardization of the technology, and there should be support from the government in order to have such new large-size biogas plants. So what we need, in my opinion, as we have already installed several large-size biogas plants, there is a need of monitoring and evaluation of such large-size biogas plants. What is the real situation? How is whether the plants are functioning or not? So I think on the basis of that, if there is something wrong with the technology, then we can have some improvements on the large size so that it is cost effective. And we need to focus basically to the large size biogas plants above 50. That's what I'm saying, because at that time we have already the designs up to 35 cubic meter capacity. And we need to standardize and quality control of these plants for the smooth operation of the system. The alternative, like in the similar way, we also need to have the alternative methods of such biogas construction techniques that is used in other countries. That may be Dinbandhu model or other designs that we do have all over the countries, world. And we should have also the kind of training. If the companies, people are making that kind of plant, large-size biogas plants, they need to provide training, not only to the installer, but also to the operators or users. Because if we are running the plant in a commercial way, we will have engine operation there, the operator must be trained. And also the pre-digestion system. And as we are using different feeding materials, I think we should also be familiar, the technology should be familiar with the application of the biogas to a range of feeding materials. And the use of biogas and slurry for more income-generating activities, besides, let's say, the agro-processing or power generation or pumping for water, we can also have some bakeries or some, there are several ways. For example, from the slurry, we can have mushroom cultivations. One, I can discuss this later on anyway, because the time is, or in that case, we need to develop, to establish a biogas research and development and training center in Nepal. I think APC has already mentioned as a excellency center, so it could be covered in that one. And on top of that, we need a strong commitment and support from the government and donor, especially for the large size biogas plants. So I would like to share something about some experience from Burkina Faso. About 2 years ago, I was there to install a 20 cubic meter biogas plants, and that was producing about 7 cubic meter of biogas per day, and it was replacing about 2.8 kg LPG gas. And the gas was used basically for mango slice drying, and the dry mango slices, they have a good business in European countries, especially in France. And now I think they are in the monitoring and evaluation phase of that project. I do not know the outcome of that result. Then I have also been in the Philippines to do the monitoring and evaluation of the plants that ICRC has been installed. And I have visited 5 plants installed in the detainees in the Philippines. In Cagayan de Oro, there is a 25 cubic meter biogas plant, and that plant is totally run with night fuel from the prisoners. There were 1,112 prisoners, and the gas was used for cooking food for the prisoners. And the excess gas was also used to make some bakeries, some cakes. You can see in the pictures there. And before biogas, about 30,000 peso per month was spent in the firewood for cooking, which has saved about 7,500 per month from biogas, because biogas was not adequate for their requirement, so they are also using some LPG gas for their cooking purpose. And yeah. So now in the conclusion, what I could say that there are irregular waste disposal problems in almost all cities and institutions. The flow and leakage of the septic tank or drainage systems create severe environmental problems and health risks to the people. Like any other biodegradable materials, food waste, human excreta, industrial waste, anything that could be used as feeding materials to produce biogas. So in order to reduce the cost of the plant, research should be carried out for large size, cost-effective biogas plant and alternative methods of construction as used in other countries, such as fiberglass biogas plants or spherical designs or Dinbandhu designs without reinforcement can be made. Such biogas plants provide renewable energy sources to the people, which reduce dependency to the use of the traditional fuel in such as firewood and other biomass, which helps in improving kitchen condition and reducing health risk. So biogas and bioslurry can be used for income-generating activities. So my recommendation will be, when using the slurry from the night soil-based biogas plants, such as fertilizer in the field, it should be in the specified range of the WHO, especially for E. coli and helminthius eggs, because if there are some pathogens, again, that will be harmful to our health, hygiene. So it is recommended that in a place where feeding material is less, pig manure or poultry droppings or whatever they do have, that could be added as co-digestions, and there should be excess water. There should not be excess water in the influent. While installing such plants, we should develop the standards and consider quality control or management of the systems. And biogas can also be used for other end-use applications, such as running dual fuel engines or biogas engines for agro-processing, pumping water, or generating electricity. And there is a need of the continuation of the biogas research and development activities in the country for the improvement of the system. Thank you.